Hi everyone. We're going to work on 1.10 polynomials with calculators today. We have three problems, three different functions, and we want to find relative maxima, minima, and intervals on which the function is increasing or decreasing. So I'm going to use my calculator here and use y equal to enter this function into my calculator. So I'm going to erase what I had here. The function is x times x minus 3. Then I need to graph this function. I go to graph here and I will see the function. So as you see, it's a parabola that from both sides is going to increase, and we have a minimum point here. We do not have any maximum point. So to find this minimum, we don't have any maximum because from both sides it's continuing to infinity. So that means there is no specific value which is higher than everything else. So second trace, number 3 is the minimum. That will give me the minimum point of the graph. So first of all, it's asking about left bound. So I go to the left side, enter, and then go to the right side of this point, because this is my minimum. I need to stay on left side and then on the right side. Enter. And then what is my guess here? So I'm going to go on almost top of it, say that this is my guess. I guess that the minimum is around here, and then enter. And that will give me this point, 1.5 and negative 2.25. So I wrote here for you, relative min is 1.5 and negative 2.25, and we didn't have any relative max. Relative mean or relative max is the same as local mean and local max. Okay, next we need to find the increasing and decreasing interval. So I'm going to put my pen on the left side of the graph. As I start from this point and continue following the path on my graph, I see that for half of the graph until I reach to the minimum point, the graph is decreasing. So that's my decreasing interval. I'm going to write that decreasing starts from this point to this point. What is the x value of the start point? It's negative infinity because I have an arrow here. So I'm going to go to negative infinity here. And then the end of this decreasing interval is here. I need to write the x value of that. Notice we always write only x value for increasing or decreasing. What is the x value of this point? That's here, x of min. So it's to 1.5. Then what is the increasing area? Starting from this minimum point to the end of the graph, the function is going up. So that's my increasing. Where does it start from? From the x value of minimum. It's 1.5 and goes to infinity. So that's increasing and decreasing. Next is the function number 2. I'm going to use my calculator to enter the function here. Okay, so this is my equation or function. Now I graph it and it's going to look like this. From these two sides, it's going to go to positive infinity and negative infinity, and we have a maximum and minimum point. So if I go to second trace, number 3, as we told you, is the minimum. So it's asking for left bound. It's already here. Then I go to the right side of that, enter. Then on top of that, and x value of minimum is 1.11, y is negative 4.0. Okay, so I wrote the relative min point here. X is this one, and y is negative 4.06. Now I need to find the maximum. So I go second trace, and number 4 is the maximum. So it's asking for left bound. The cursor should be on the left side of this point. So I move the cursor here. enter, and then to the right side of that, enter, and then on top of that. So x of max is negative 1.78 and y is 8.20. Okay, so here I listed the x and y value of relative maximum point, and this is the graph. Now I need to find increasing and decreasing area. So as I start moving my pen from left side of the graph, I see that over here from the left side until I reach to this maximum point, the function is increasing. So I have an increasing area, increasing interval, which starts from negative infinity. So increasing once again is from negative infinity to the x value of this point, which is our maximum point. What is the x of max? Is negative 1.78. Then I'm going to put a union here to write the next increasing area after that. But before that, like from this max point to this minimum, the function is decreasing. So I have a decreasing area here. I'm going to write this first, and then I will write the next part of increasing. Decreasing starts from this point. So x of max, which is negative 1.78. Once again, only the x values. And then x of min, that's the end point of this decreasing area. It's 1.11, and that's it. That's for decreasing. Now the next part again of this function is increasing. So I need to write that the x of the start point of this increasing interval is x of minimum, which is 1.11 x of minimum, and then end of that is infinity. So this will be the increasing and decreasing. Okay, then the next problem, I already entered the function into my calculator, and now I'm going to graph that, and this is how the graph looks like. We have a maximum point here, a relative maximum or local maximum here, another local maximum over here around this area, and we also have a minimum point here. We do not have any local min or local max here. That was all of the local min and maxes, and from these two sides the function is decreasing. Okay, so I can write the max and min here. So I go second trace. Let's start with the maximum point. Let's say this one. Okay, so I need to go to the left side of that, enter, then go to the right side of this point, enter, and then on top of that. So the maximum is negative 1.32 for x and 4.91 for the y value. So I wrote the x and y value of local maximum here, and then the second local maximum, I'm going to go second trace again, number 4, and this is the point that I'm looking for. So I need to go on the left side of this point, let's say somewhere like here, and the right side of that, enter, and then on top of that 1.6 and negative 0.60. Okay, so that's my other local maximum. Then I need to find the local minimum. Second trace and go to number 3. I have to go on the left side of the point, then to the right side, and then on top of that. X is 0.46 and y is negative 2.9. And this is my local minimum. The graph was something like this. I'm going to graph it here on this paper, on this screen. So it was something like this. Let's make it a little bit better. So it was something like this. Okay. Now it's asking for the interval that function is increasing and decreasing. I'm going to start from here. The function is going to increase as I move from left to the right. Keep in mind again, start from left and move to the right side, increasing until reach to this point. So I have an increasing area here. Let me write that here. This is for the previous problem. Now here, increasing area starts from negative infinity and ends at x value of this maximum point, which is negative 1.32. Okay, then the graph is going to decrease until it reaches to this minimum point. So I'm going to write the decreasing here. Let me write it here. I don't have enough space, so I'm just going to write that here. The decreasing area starts from x value of maximum, which is negative 1.32, and ends at the x value of this minimum, which is 0.46. So that's a decreasing interval. Then this little one over here is an increasing because it's going up. So it's going to be from the x value of this minimum point. So the next one, I'm going to put a u here for increasing from the x value of minimum, which is 0.46, to the x value of the second maximum that I have here, and that's 1.6. Now the next part of the graph again is decreasing, it's going down. So it's going to start from 0.46, which is x value. Oh, I'm sorry, not 46, it's x value of this maximum point, which is 1.6, to infinity, because we have an arrow on this one. So that's increasing and decreasing area. Now let's go to the board problem that we have here. I'm going to erase what we just wrote here. Okay. A rectangular area is to be fenced against an existing wall. The three sides of the fence must be 1050 feet long. Find the dimensions of the maximum area that can be enclosed. What is the maximum area? Okay, so we have a rectangle here. One side is a wall, and the other three sides are going to be fenced. It's a rectangle, so that means whatever is this side, let's call that x. The opposite side over here is going to be again x. All three sides should add up to 1050. That means this other side is going to be 1050 minus 2x. Why? Because let's call this one width and this one L, okay? Then L plus this width, which is x, plus the other one, which is again x, should add up to 150. So L plus 2x will be 150, and L will be, not 150, I'm sorry, 1050. 1050 minus 2x. So that's why the other side is 1050 minus 2x. Now it's asking us to find the area, basically, maximum area and the dimensions for maximum area. So we know that area is length times width. I'm going to replace whatever I have for L and W here. So length was 1050 minus 2x, and the width is x. So I can write it as a function of x. A of x is this. That's the equation for area. Now I need to find the maximum of that. So I need to go to my calculator and enter this to my calculator. So y equal to 1050 minus x times x. Then I'm going to graph it. But as you see, we don't see like a perfect curve here, perfect graph here. That's why, that's because the window is not big enough. So I need to change the window. The window is negative 10 to 10 and negative 10 to 10 for both x and y. So I need to make some changes. As you see, we have a big number like 1050 here. Like our y value is going to be 1050 times x times x. So it should be a really big number. We're going to basically use a trial and error and some kind of guess here. So by looking at these values, I'm trying to guess what is the best value that I can use for my window. I think the y value should be like something really big because I have I mean 1050 here, and it's going to be multiplied by x. So maybe I can use a really big number. Let's try 10,000 because 1050 is going to be multiplied by something else. I'm going to use 10,000 to see what happens. I'm not even sure if that is going to be like the perfect, but I will try it. And the x values, let's just see what happens here. Okay, so I have something here, but still this is not perfect. So I need to make my x and y bigger. Um, let's make the x max. I don't know, I'm gonna try 300, and the y max, let's make it 100,000. Okay, still it's not big enough. So I'm gonna make this one the x value as 500 and this one as 200,000. Okay, still it's not big enough. Okay, so this time I changed the x maximum as 1,000 and y maximum as 500,000. Let's see what happens. Okay, so this one looks better. Now I have almost all parts of my graph. I can even make the x value a little bit bigger. Let's make it 1,200. Okay, this is really perfect. So that's the graph of my function, which shows the area of this rectangle with respect to x. Now it's asking for the maximum area. So here, this graph that I have here, the x-axis is just the width, which is x value, and the y-axis is the area. So if it's asking for the maximum area, that means if I find the y value of this point, that will give me the maximum area. How do I find the maximum area? Just go to second trace and number 4, maximum. So I need to go on the left side of this point, then on the right side of the point, and on top of that. Gives me 525 and 27, 5, 6, 25. Okay, so if x value is 525 feet, then we will have the maximum area, which is this number, square feet. Okay, so let's go to the next problem. A market analyst working for a small appliance manufacturer finds that if the firm produces and sells X blenders annually, the total profit is going to be this function. So that means if I graph the function, the x-axis will be the number of the blenders and the y-axis will show the profit. Then saying graph the function p in an appropriate viewing rectangle and use the graph to answer the following question. So I'm going to graph the function here. Let's put that here. And this is my function in y equal to, then I need to graph it. but obviously our window is not appropriate for our graph. So let's go back to negative 10 to 10. That's what we had before and see what we are going to have here. Still it's not big enough. This is small. So I need to change my window. Looking at the graph, I mean at the function, I see that the function is something, something, something minus 372. So the number, let's say if everything here is 0, should be at least negative 3372. That should be my y value. So I'm going to make it even a little bit um, smaller than negative 372. I'm going to make it negative 500. Okay. And of course, the highest value should be also something like that, a big number. Let's try, I'm going to try 600. And then the x value, um, so that's the number of the blenders. Of course, 10 blenders would not be a really good number here. I'm going to try 50, see what happens. Okay. Okay, this is not bad. I know that I'm going to reach to something. So let's try a different number. Here I changed the x max to 400 and the y max to 4000. And that's it. The graph is kind of perfect here. So I just use different values to find the best value for x mean, x max, and y mean and max. Okay, so this is my graph. Let's graph that here. Whatever we had, I'm going to graph it here. It was something like this. Part A says when just a few blenders are manufactured, the firm loses money or the profit is negative. How many blenders must the firm produce to break even? Okay, so as I look at the graph, it's obvious that if I produce just a few number of blenders, that is when the x value is a really small number, then the profit is negative. It's below the x-axis, that means it's negative. So that's the first part. Now it's asking how many blenders must the firm produce to break even? Break even means we do not have any profit and also we do not have any like loss here. That means the profit is 0. It's not a positive number, not even a negative number, it's equal to 0. So that's the point that I'm looking for. I need to find the 0 of the function because at this point the graph is crossing the x-axis. So I go to second trace and number 2, which is 0. Okay. Um, since this is my point, I need to go to the left bound of this point. So I move the cursor. Okay, this is good. Left side, and then right bound, and then on top of that. It's 25.23. That's when the y value is 0. So when x is 25.23, then the y is 0, or basically we have the break-even point here. So the number of blenders should be this value, which because the number of blenders cannot be a decimal numbers, I'm gonna make it like 25. If I make 25 blenders, then I will have the break-even point. Okay. Next part is asking, does the profit increase indefinitely as more blenders are produced and sold? If not, what is the largest possible profit the firm could have? Okay, as you look at the graph, you will see that the profit is going up until it reaches to this point. This is the maximum point. And if I produce more blenders after this point, I'm not going to have more profit. The profit is going to decrease and going down. So for the first part, does the profit increase indefinitely? We're going to say no. It will stop increasing at some point and go down after that. Then what is the largest possible profit? That means we need to find the y value of this point. What is the maximum profit? So I go to my calculator, second trace, and then 4, which is maximum, left side of the point, and then right side of the point. This is good. And then on the top of that, enter. So if I produce almost 166 blenders, then my profit will be 32.76. So maximum profit will be 32.76 if the number of the blenders is almost 166. Let's go to the next problem. We have an open box here. We want to make this open box. An open box is to be constructed from a piece of cardboard 20 centimeters by 20 centimeters by 40 centimeters. By cutting the squares of side length x, like these little squares from each corner, and folding up the sides as shown in this figure. So we have a cardboard. From each side, we're going to cut little square. From each corner, we're cutting a little square by the side length of x, and then we make this shape. It's asking express the volume V of the box as a function of x. We know that volume is length times width times height. Okay, now I need to find length, width, and height of this box. Of course, the height is x, that's the height. What is the length? The length is made out of this side, 40, which I'm cutting one x from this side and another x from the other side. So whatever I have here in between them, it's 40 minus 2x. That's my length. And then the width is going to be 20 minus 1x from here, another x from here. So the width is going to be 20 minus 2x. Now I have all of them. Now the volume could be written as function of x, like f of x, equal to length, which is 40 minus 2x, times width, which is 20 minus 2x, and the height, which is x. So that's my function. Now it's asking what is the domain of V? Use the fact that length and volume must be positive. So here, let's say the width that I have here, the maximum of the width could be 20, but I'm cutting the x values from both sides. It's asking what is the domain of V, because V is a function of x, so I'm looking for the x values that I can use here. What are the domain of the x values that I can cut from both sides of x? Okay, we know that this value 20, or the width should be a positive number. It's 20 minus 2x. If this x is something, let's say 10, it will be 20 minus 2 times 10, which is 20 minus 20, and that's 0. Okay, but if I use a number bigger than 10, minus 2 times 11, it will be 20 minus 22, which is negative 2, and the width cannot be a negative number. So that means the maximum value that I can have for x is 10. The x could be at least 0, because the side length that I can cut from this square cannot be a negative number. So it can start from 0 and the maximum value could be 10. So that will be the domain of phi. Next is asking, use your calculator to find a graph of the function and use it to estimate the maximum volume here. Okay, I'm going to use my calculator to here's my function in my calculator and I'm going to graph it, and once again we do not have a perfect window, so I need to make a bigger window here. The x value, we already had the domain, should be something between 0 and 10, which my window here is already between like -10 and 10. I'm going to make it a little bit bigger because I see the inside of the x, like the maximum of 8x, but I need to make it a little bit bigger to see more of this function. So window could be, let's make it, I don't know, 30. Now, what is the y value, maximum y value here? Okay, here I have 40 minus 2x times 20 minus 2x times x. So it's 40 times 20 times, again, something else. So 40 times 20 is 800. The x could be at most 10. So 800 times 10 is 8,000. I'm going to try that, see what happens. 8,000. Okay, looks like the y value is too big here and I need more of the negative side of that. So let's make this, I'll try 3,000 for the y max and -1,000 for the y min. Okay, this is almost good. I need a little bit more of this side. I'm gonna make it -2,000. Okay, this looks really good. Now, it's asking to find a maximum volume here. So of course, that's going to be this point. We have a maximum here. So I go second trace and maximum, which is 4 on the left side, enter. And then on the right side of that, enter, and top of that. So the maximum y value or the maximum volume will be 1539 if the x is 422. So if x is 422, the maximum volume will be 1539. Okay, so that's the answer. Now let's go to the next problem. The number of identity theft cases from 2005 to 2010 can be represented by the function f of x equal to this value, where x represents the number of the years since 2000. Approximately when will the number of identity theft cases reach 20,000? Okay, so let's go to our calculator again and enter the function to. After entering the function into calculator, as I graph it, again, I don't see anything. Let's see, what should my x and y be here? The problem itself is saying that the x value is from 2000 to 2010. That means if I graph the function, the x-axis is the number of the year, which we are considering 2005 to 2010. So the x should be a really big number here. And the y value, as I see, I have the 10,000 here. So of course the y value should be something bigger than that. And also here it's asking when is the number of the cases 20,000. So it should be a really big number here. So I'm going to try that here. The x min I'm going to change the X max to 2040 because it's from 2005 to 2010. So X will start from a negative value and like go to 2040. And then the Y maximum, I'm going to use 2500, I mean 1000. Okay, we are missing something here. Let's see how we can change it. Okay, let's go back to the question. It's saying the number of the cases from 2005 to 2010, and it's going to, the X represents the number of the years since 2000. So that was my actually the mistake that I made here. It's starting from 2000 and going to 2010. So basically the X value is a small number between 0 and 10. So I go to the calculator, I changed it to 40. It could be even 30 or 20. Let's keep 40 here. And the Y value, just change it to a bigger number like 30,000 and see what happens. And okay, so this one looks better. So this is my graph. Now it's asking approximately when the number of the identity theft cases reach 20,000. Like if this is my graph and this Y value is the number of the cases, it should be like 20,000. So I need to see where my function has a Y value of 20,000, and that should be this point. Like if I draw a straight line at 20,000, Y equal to 20,000, this point will be where my function has a Y value of 2,000. So I need to find that point. I'm going to Y equal to and define another equation, 20,000. Okay. So I have two functions here. Basically, I want to find the intersect of this horizontal line of Y equal to 20,000 and my graph. That's the intersect of these 2 points. To find the intersect, I go to second trace, and number 5 gives me the intersect. Okay, now it's asking for the first curve. I need to see where is my cursor. Find the cursor. I'm going to move it around to find the cursor. It's here. So as the cursor is standing on the first one, I enter, and then it's asking for the second curve. I move the cursor to the second one. It's here. Okay, enter. And what is my guess? Where do you think the intersect is going to be located at? It's here. So I'm going to move the cursor to that point. Enter. And that's the intersect. When x is 7.40, y is 20,000. Okay, so when x is 7.4, then y is 20,000. So what does x equal to 7.4 mean? Because we know that x-axis is the a number of the years starting from 2000 and going to 2010. So when x is 7.4 something, that means the year is 2007, almost 2007. So at year 2007, the number of the cases will be 20,000. So this was today's lesson. Have a good day.